In this video we are going to look at the trigonometric identities. For National 5 Maths you need to remember two trig identities, both of which are derived from the unit circle. But what I'm going to do is I'm just going to show you them and then we're going to do a few examples. Okay, so our first trig identity is sine squared x plus cos squared x equals 1. Just a wee note, sine squared x is just the same as sine x squared. So if you see sine squared x, that means sine x times sine x. Okay, but that's just an aside. Our first trig identity is sine squared x plus cos squared x equals 1. Let's have a look at what we can use with this. Okay, so with our sine squared x plus cos squared x equals 1, what we can do is we can actually derive two other equations from this. If we were to treat this like a normal equation, what I can do here is if I subtracted sine squared x from both sides, I would have the equation cos squared x equals 1 minus sine squared x. And similarly, instead of subtracting sine squared x, if I subtracted cos squared x from both sides, I would obtain sine squared x equals 1 minus cos squared x. Okay, so the main one that we're looking to remember, though, is this top one here. I'll just get the highlighter. This top one here, because it's from this original identity that we can derive these two. The other trig identity that we have is tan of x equals sine of x over cos of x. Like for example, we could see this if, for example, we did sine of 70 divided by cos of 70. That would give us the same answer as tan of 70. Often we may see things such as tan squared x. Tan squared x simply means tan x times tan x. And if we were to apply our trig function, sine over cos, that would mean sine x over cos x times sine x over cos x, which would give us sine squared x over cos squared x. Okay, so tan squared x is sine squared x over cos squared x, tan cubed x would be sine cubed x over cos cubed x, and so on. What we're going to do now is we're just going to look at a few examples. Okay, so every single example, when we're looking at trig identities, will revolve around the two trig identities here. Sine squared x plus cos squared x equals 1, and tan x equals sine x over cos x. Okay, let's imagine we've been given the question, show that 1 minus sine squared x over cos x equals cos x. Okay, so see when we've got a show that question or a proof question, we need to try and prove that the left hand side of our equation is equal to the right hand side of our equation. Okay, so here's certainly how I approach these trig identity problems. Okay, step 1, look at my left hand side. And we're just going to focus solely on the left hand side. Okay, so step 1, look at the left hand side of our equation, and just from this left hand side, what trig identity shall we use? Okay, so we've got 1 minus sine squared. Okay, so the top one is the only one that's involving sine squared, so I think I'm going to have to use that. Okay, so let's see what else I can do. So I have got my top line is 1 minus sine squared x. I'm going to be using this formula here, this identity, but I don't have anything looking like 1 minus sine squared x. But if we recall back to a previous screen, just rewrite the formula. Equals 1. If I subtracted sine squared x from both sides, I would have cos squared x equals 1 minus sine squared x. And we can now see that what I've got here is what I've got here. So I now know that 1 minus sine squared x is equal to cos squared x. So I've got cos squared x divided by cos x. Cos squared x is just the same as cos x times cos x, and we're dividing that by cos x. And if we can link this back to like algebraic fractions or simplifying fractions, we can cancel down here because things are multiplying. I can cancel down these two cos x's, and that would leave me with cos x. That is what I'm looking for. I want to prove that it is cos x. That equals the right hand side as required. Okay, we're going to look at another 3 or 4 examples just so we can show you like how to approach these problems. Okay, in this example we've been asked to show that 3 sine squared x plus 3 cos squared x is equal to 3. So step 1, let's look at our 2 trig identities. And what one do we think we should be using? So let's have a look. We've got sine squared and cos squared and are adding. So it looks like we're going to have to apply this one here. But this trig identity is only involving sine squared and cos squared. Here we've got 3 sine squared and 3 cos squared. So we're going to need to manipulate the left hand side a little bit. Okay, so as before, we're going to try and prove that the left hand side is equal to the right hand side. There's not much I can do with left hand side, but we can note that both of them have got a 3 in front of them. That means both of them can be divided by 3. Both of them are multiples of 3. So what we're going to do is we're going to take out a common factor of 3. So we're going to have 3 bracket sine squared x plus cos squared x. And that equals. So inside my bracket I've got sine squared x plus cos squared x. Sine squared x plus cos squared x is 1. So this is the same as 3 times 1, which is 3, which is what we've been asked to show, which is equal to the right hand side as required. Okay, in this example we've been asked to show that sine cubed x plus sine x cos squared x is equal to sine x. Okay, so as before, we're going to try and show that the left hand side is equal to the right hand side. Okay, so let's have a look. We've got sine cubed, sine, cos squared. We're adding, so we're not really got anything dividing here. So it looks like we've got cos squared here and cos squared here. So it looks like we're going to need to apply this formula. But we can note that it doesn't look anything like this. We're going to need to manipulate this left hand side. But how can we do that? If we note here, in this left hand side, we've got sine cubed and a sine here. Both of them are multiples of sine x. So what I can do is I can take out a common factor of sine x. Okay, so sine x times what is sine cubed x? That would be sine squared x. And then sine x times what is plus sine x cos x? Well, that's going to have to be, plus sine x cos squared x, that's going to have to be plus cos squared x. Okay, so we're going to have sine x, and that is multiplied by sine squared x plus cos squared x, what we've got up here, and we know that that's equal to 1. So we've got sine x times 1, which is sine x, and that is what I've been asked to show. That is equal to the right hand side as required. Okay, in this example we've just been asked to simplify tan x cos squared x. So we're not asked to prove or to show that, so we're just going to try and solve this. Okay, so things to note. What trig formula should we be using? What trig identity should we be using? So we've got a cos squared, but we've not really got any adding involved. We do have a tan x here. So let's have a look. Tan x is the same as sin x over cos x. So what I'm going to do is I'm going to replace tan x with sin x over cos x. And that is multiplied by cos squared x. What we can do now is we can simplify a little bit. This cos x would cancel out with one of these cos x's, which would leave me with a final answer of sin x cos x. Okay, so in this final example, we have been asked to show that sin x divided by tan x is equal to cos x. Okay, so we're asked to show that, so we need to prove that the left-hand side is equal to the right-hand side. Okay, so let's look at the left-hand side. Sin x divided by tan x. We've not got any sin squared, so we've not got any adding or subtracting. But we do have a tan x. So what we're going to do is we are going to replace tan x with sin x over cos x. And immediately we can see that this is starting to get a bit messy. We've got sin x divided by sin x over cos x. What I'm going to do is I'm just going to work at the side here just to show how this is going to work. So sin x we can just write the same as sin x over 1. Sin x is the same as sin x over 1. And we've been asked to divide that by sin x over cos x. We're essentially dividing by a fraction. Sin x over 1 remains unchanged, but when we're dividing by a fraction, divide becomes times and we flip the fraction upside down. Okay, so what I can actually write now my left hand side as is I can write it as sin x cos x divided by sin x. And then hopefully we can spot that because we're multiplying, we can cancel our sin x's, and that would leave us with an answer of cos x, which is equal to the right hand side, which is what we were shown, what we were asked to show. Okay, so the main things we need to remember is these identities. If we see sin squared and cos squareds involved in a question and there's either an adding or a subtracting, you should be applying some form of this equation. If you're seeing tan x, you should be applying sin x over cos x. Thanks very much.